Hey guys, this is the Part-Time Economist, and today we are continuing learning about statistics. Now, before we do any of these crazy analysis or break out our calculators, we have to have some basic data to work with. So this section is going to be talking about, one, what are different types of data, and two, we're going to talk about how we gather that data in an upcoming lesson. Now, first off, we need to know what a variable is. A variable is just some characteristics. Color is a variable. This purple shirt is different from a green shirt or a blue shirt, right? Age, height, weight, income, anything like that is a variable. Now, an observation is a member of the collection, the data set that we are studying, right? So if I ask 10 different people what their favorite ice cream is, I have 10 observations. If I ask 5 people what their favorite animal is, I have 5 observations. Now, the univariate, bivariate, and multivariate sounds a little bit confusing, but it's really not when we think about it. Uni means one. So a univariate analysis would be something like asking 10 people what their favorite ice cream is, right? They say chocolate, vanilla. I'm just asking them one simple question, right? Now, bivariate is 2 characteristics. So I could ask what their favorite flavor of ice cream is, and then I could also ask if they are a boy or a girl. I'm asking 2 separate characteristics. Now, the important thing is that there could be many flavors of ice cream, right? Chocolate, vanilla, strawberry, but it's one characteristic. It's flavor of ice cream. So 2 characteristics is bivariate. Bi means 2. Multivariate is many characteristics. So I could be asking age, income, education, choice of college major, right? Multivariate means I'm looking at multiple characteristics. So the important thing and the interesting thing is that the more characteristics we have, the more detailed analysis we can do. So if I simply ask 10 people what their favorite ice cream is, all I can say is, well, the most favorite ice cream was this, you know? But if I have bivariate, I can say, well, it appears that boys preferred chocolate more than girls, right? I can do more analysis. And then as we move into multiple characteristics, I can say, well, it appears that people make more money based on staying in school longer and choosing this major and living in this area of the country, right? I can do more comparisons because I have more variables. Now, as we move on, there is categorical data, which is called qualitative data. There is also numerical data. So this is kind of easy to understand if we think about the words themselves. Qualitative is like a quality, right? So what type of car are you driving? What type of movie is this? What type of tree? Do you notice the pattern? It's all about type of. So qualitative or category, we're putting things in categories, but we're not necessarily counting them, right? And then there's a specific type of thing called a binary variable, which just means yes or no. So instead of asking you, do you have an associate's, bachelor's, master's, or PhD? I simply say, do you have any form of college degree? It's a yes or no question, which is why it's called a binary variable. Now, numerical data is all about numbers, right? So I don't care what kind of car it is. I'm asking how many miles it has on it, right? I don't care what kind of tree it is. I care about how long it's been growing, how tall it is, right? So it's a difference between putting things in categories and using numbers to describe things. So age, income, these are examples of numerical data. Now, 2 specific types of numerical data to be aware of are discrete data and continuous data. Discrete data is something that can be defined as a countable number. So, for example, if you go to the store and you buy 5 energy drinks, right? You can only buy in whole numbers. You can't buy 5.5 energy drinks, right? You can't, if I ask how many people are in the room with you, there could be 5 or there could be 6, but there can't be 5.5 people, right? Continuous data is different because it can be on a scale, right? So if I ask how much you weigh, you might tell me that you weigh 150 pounds. But if you were to step on a more accurate scale, you might actually weigh 150.5. And then if we put you even on a more accurate scale, you could weigh 155.53 or 0.5321, right? You can become more and more accurate in your measurements because you're on a continuous scale. You're not confined to whole integer numbers. I hope this video has been useful. This is the Part-Time Economist, and I will see you next time when we're talking